We're asked to sketch the graph of f of x equals x squared minus 4 all over x cubed minus 2x squared minus 9x plus 18. And I've written down the things I'm going to think about as I go through and sketch this. I want to find any x-intercepts, the y-intercepts, the location of any holes, the vertical asymptotes, any horizontal asymptotes, and then I'm going to sketch the graph, and I might have to plot a few points as I go through it. Okay. To find the x-intercepts, the location of the holes, and the vertical asymptotes, I need to have both the top and the bottom factored. The x-intercepts happen anywhere a rational function's numerator is equal to 0 when that rational function is in its lowest terms. The vertical asymptotes happen where the bottom's equal to 0, but only when I'm in lowest terms, and the holes happen wherever I might have canceled off any common factors. And so I would go on and recommend that anytime we were asked to graph a rational function, we factor first. So the top's pretty easy to factor. It's the difference of squares, x minus 2 times x plus 2. And now I need to factor the bottom. And we could actually use any of the information we know about factoring polynomials or finding zeros of polynomials. But I'm just going to use an old factoring trick. So down here in a scratch area, I'll just go on and factor this. One of the factoring tricks you might have seen a very long time ago is factor by grouping. Factor by grouping works when we compare two groups of things so that when I factor out part of it, I'm left with a common binomial. So here I'm going to factor out x squared. When I factor out that x squared, it would leave me with an x minus 2. Now my goal is to factor something away from this pair of terms so that I'm also left with an x minus 2. So I'm going to factor out a minus 9, leaving me with an x and a minus 2. All right, so this is equal to this, and now the whole idea is I have x squared times some x minus 2 and minus 9 times the same something. So I'm going to factor that x minus 2 out front. So I have x minus 2 out front, and what I'm left with when I factored that out of both terms is an x squared minus 9. Okay, so I've started to factor the bottom. I can write that down there, but I can go on and notice that this is the difference of two squares. So I have the x minus 2, and then I have x minus 3 times x plus 3. And I see that I am going to have a hole because I have two terms that cancel. By factoring first, I have a simplified expression that's equivalent for every value of x except for x equals 2 to use to figure out everything else I'll need to know. Okay, so I know I'm going to have a hole because I had that canceled factor, and that hole is going to happen when x is equal to 2. And eventually I want to fill in a blank here. I want to fill in what happens as the y-coordinate of that hole. But for right now, I'll just say, hey, there's a hole where x equals 0. The x-intercepts come from the zeros of the top when I'm in lowest terms. Well, here I'm in lowest terms, and the 0 of the top is minus 2. If I plug in a minus 2, I get 0 on top. 0 divided by any real number is 0. Y-intercept, I need to find f of 0. I can use this formula, or I could use that formula, or any of the ones in between. Using this bottom one, I would get a 2 on the top, and on the bottom I'd have minus 3 times positive 3 is minus 9. If I use this one, I'd end up with minus 4 over positive 18, which is also minus 2/9. So there's my y-intercept. My vertical asymptotes happen where the bottom's equal to 0 when I'm in lowest terms. So I have a vertical asymptote at x equals minus 3 and at x equals positive 3, where those two terms are equal to 0. Now, when someone asks you to write down vertical asymptotes, please give them equations. Vertical asymptotes are lines. They're vertical lines. They should always be in the format x equals something. This is a line at x equals minus 3, and this is a line at x equals 3. Don't just write numbers. That's a little not informative enough. We need more information there. We want the equations of those lines. All right, the horizontal asymptote. I know the 3 rules I'm supposed to follow. If the degree of the top and bottom were the same, I take the quotient of the leading coefficients. If the degree of the bottom is larger, my horizontal asymptote is at y equals 0, and if the degree of the top were larger, my horizontal asymptote wouldn't exist. Well, in this one, the degree of the top is 2 and the degree of the bottom is 3. If I look at this reduced expression, the degree of the top is 1, and I have an x squared on the bottom. So anywhere I look, I would get a horizontal asymptote at y equal 0. And just like with the vertical asymptotes, writing 0, just the number 0, would be ambiguous. We want to write y equals 0, so we know we're talking about a horizontal line. I'm ready to start the process of graphing this function. So what I've done is I've written all the information we just found over here kind of summarized. So I can go on and start plotting the interesting parts. At minus 2, 0, I have an x-intercept. At 0, minus 2/9, I have a y-intercept. At x equals minus 3, I have a vertical asymptote. At x equals positive 3, I have another vertical asymptote. And at y equals 0, I have a horizontal asymptote. So, I think I need more information. At x equals 2, somewhere in there I'm going to have a hole in the graph. So somewhere on that vertical line there'll be a hole wherever my function goes. But right now I feel like I need to plot more points. So, I'll pick some x's and we'll find some y's. So let's plot at least one point out here. So let's put minus 4 in our table. Let's see, I have a point here and I have a point here, so let's put 1 in our table. And I'm going to go on and put 2 in our table. And we remember that's a special place, and we're going to see why I can put it in the table and why that'll tell me where the hole is. And then 4 can go into our table. So, going back to this board, I'm going to use this simplified expression. So my y values will be x plus 2 over x minus 3 times x plus 3. And just to make my work as simple as possible, I'm going to plug those values into my graphing calculator. Now I haven't entered this function in yet, so we can do that together. On top, I'll have x plus 2. Notice I've used parentheses. Some of y'all might have nicer calculators where it's going to put everything on top once I hit the division symbol, but if you have a calculator like mine, you have to be careful. And then on the bottom, I have an x minus 3 and an x plus 3. And again, notice I have x minus 3 in parentheses because it was in parentheses, times an x plus 3, but then I have the whole bottom in parentheses too. So I make sure the calculator knows what's on the top and what's on the bottom. Another option here would be to multiply that out to be x squared minus 9, and then that would just be in one set of parentheses on the bottom. All right, so now I'm going to go into the table, because I have my table set up to where I can input specific values of x I choose. And again, in a previous video, I showed you that if you go into the table setup and you choose that to be asked, then you get to pick the x values. So I'm going to go back into the table. I want minus 4, positive 1, positive 2, and 4. So I'm just going to write down these decimal approximations, and I'm just going to round to 1 decimal place because I'm just trying to get a pretty good sketch here. Okay, so what's going on at 2? Well, that's supposed to be the location of my hole. So I think that minus 0.8 fills in this blank. What's happening, I can't plug 2 into this expression because I get 0 on the bottom. Right, and I can see that here where I factored it, and I can't divide by 0. If I plug 2 into here, I get an expression. Well, these expressions literally give me the same y value everywhere except for at 2. So if I use this expression, it tells me the y value where that hole should go, because all the points near 2 behave the same on both graphs. All right, so I'm ready to plot these points. I'm going to go on and plot the one at 2 comma minus 0.8 with an open circle, because that's where I canceled that common factor. That's where my hole will be. At minus 4, I'm at minus 0.3. At positive 2, I've already plotted my hole. At 1, I'm at minus 0.4. And at positive 4, I'm at positive 8.5. I don't know why I wrote out more than one decimal place, about 0.9. All right, not a lot of information here, but my graph should tend towards its asymptotes. If I wasn't sure about what the graph would do, I'd plot more points. All right, so I've got the graph of my rational function sketched out here. And I haven't looked at it on my graphing calculator screen yet. So I'm gonna hit the graph button, and I hope it looks like that. Otherwise, I have to refilm this video so that I look cool. All right, so here we see the graphing calculator trying to sketch this part out. And then it shoots up because it's trying to connect 2 points. But I see the part that looks like this. The graphing calculator can't tell me where the hole is. And then I see this part sketched out fairly well. So I would claim the graphing calculator makes me feel like we did this very well, and we did better without using the graphing feature of our calculator, only using it to do some arithmetic that we totally could have done on our own if we wanted to.